Okay, here's a wild thought for you. What if life, at its very core, isn't just about messy, complicated chemistry? What if it's actually a perfectly tuned quantum orchestra, playing an invisible symphony inside every single one of our cells? It's a pretty mind-bending idea, and today we're going to unpack the incredible physics behind it. I mean, just picture it. Inside every living thing, there's this constant chaotic dance of molecules. It seems totally random, but what if it's not? For more than half a century, some physicists have had this nagging suspicion that it's all a coherent performance, guided by the strange and, frankly, powerful rules of quantum mechanics. But, that idea immediately slams into a huge wall, a massive paradox. We know that quantum effects are incredibly delicate. They really only show up in the coldest, most isolated, quietest places in the entire universe. So how on earth could this fragile quantum order survive in the hot, wet, and just plain messy environment of a living cell? So yeah, let's dive into what we can call life's quantum paradox. To really get why this whole idea is so radical, you have to understand just how hostile a cell should be for anything quantum. Think about those giant, crazy-looking quantum computers you see in the news. To get those quantum bits to even hold their information, scientists have to cool them down to a tiny fraction of a degree above absolute zero. And they have to shield them from the slightest vibration. It's literally the quietest, coldest, most isolated setting imaginable. And then you have a living cell. It is the complete and total opposite. It's a bustling city at rush hour. It's warm, it's sloshing around with jiggling water molecules, and there's a constant storm of chemical reactions going off. By all the rules we thought we knew, any delicate quantum state should just fall apart in an instant. So how could life possibly overcome this? Well, way back in 1968, a physicist named Herbert Fröhlich came up with this absolutely brilliant solution. He imagined a way for life to not just survive the noise, but to actually use its own energy to create a totally unique kind of quantum order. The big idea here is called Fröhlich condensation. And get this. Instead of making things cold to get order, Fröhlich's theory says life does the opposite. It pumps energy in. Just imagine an orchestra where every musician is just playing random notes. Total chaos. But now, what if a conductor could use a powerful, steady blast of energy to force every single instrument to lock onto one single, powerful, perfect note? That, in a nutshell, is a Fröhlich condensate. And this is really what makes Fröhlich's idea so perfect for biology. You've probably heard of a Bose-Einstein condensate, right? That's like freezing water into a perfect crystal of ice. You get order by taking energy away. But a Fröhlich condensate is the opposite. It's more like a laser. You pump it full of energy, not to make it chaotic, but to force all the light into one powerful, coherent beam. It's order from energy, not order from cold. Okay, so if the cell is an orchestra, who's playing the instruments? And who's the conductor? Let's break down the essential components that the quantum physics model says you absolutely need to make this symphony happen. All right, there are 4 crucial players. First up, you've got the musicians. In physics speak, these are phonons, basically the collective vibrations wiggling through molecules like proteins. Second, you need an energy source, which is just life's metabolism, that constant pump of energy from things like ATP. Third, you have the background noise, which is simply the heat and chaos of the cell itself. And finally, and this is the really clever part, you need the conductor. This is a non-linear interaction, which is just a fancy way of saying these vibrations can talk to each other and influence each other, kind of like musicians listening and adjusting to find a common rhythm. And look, while this whole orchestra thing is a really great way to picture it, I want to be clear. These 4 elements, the phonons, the energy pump, the thermal bath, and that nonlinear interaction, are the precise ingredients laid out in the actual rigorous quantum equations. So this isn't just a nice story. It's built on some really solid physics. So what happens when you get all these pieces in the same room and you start cranking up the energy from that metabolic pump? Well, it's not a slow, gentle change. It's sudden. It's dramatic. It's like a quantum crescendo. Before you hit a certain energy level, all that vibrational energy is just scattered. It's all over the place, across many different frequencies. It's just noise, like an orchestra warming up, right? Everyone's just doing their own thing. But just watch what happens when that energy supply crosses a critical point. And bam! The whole system just snaps into this new state of order. Just like the physics predicts, all that excess energy suddenly and collectively pours into one single mode, the lowest frequency it can find. The entire orchestra has locked onto one single,
powerfully amplified note. That, right there, is Fröhlich condensation in action.
And we're not talking about just any random note. The theory actually predicts its pitch. The frequency of this cellular hum falls right within the terahertz range of the electromagnetic spectrum. We're talking somewhere between 100 billion and 10 trillion cycles per second. That's a specific, measurable fingerprint we can actually go out and look for. So, a quantum symphony humming away in our cells. It's an incredible idea for sure. But so what? Why would life even bother to do all this? Well, this is where it gets really exciting, because the potential implications are just huge. This quantum coherence could be the secret sauce behind some of biology's most amazing tricks. It could explain how energy zips around with nearly 100% efficiency during photosynthesis, or how huge, complex molecular machines coordinate their actions from opposite sides of a cell. It really offers a whole new way to think about how life organizes itself, moving way beyond just simple chemistry. And you know what the best part about all of this? This isn't just some cool philosophical idea. It is a real, testable, falsifiable scientific hypothesis. Because the theory predicts that very specific terahertz frequency, scientists can literally point detectors at living cells, give them a little energy boost, and look for that specific electromagnetic glow, the actual physical proof of the condensate. Which leaves us with this one last really big thought. We've always seen life as this masterpiece of chemistry, right? But what if it's also a masterpiece of quantum engineering? I mean, if our cells figured out how to create and maintain this stunning level of quantum order in the middle of all that heat and chaos, it just begs the question, what other quantum secrets has life mastered that we haven't even thought to look for yet?